Okay. So, let us discuss that we have discussed about the speech perception. Okay. So, this class I will maybe it is required 2 lectures. So, during these 2 lectures we discuss about the how human being perceive the speech. Okay. So, if you ask the why we have to know about the human speech perception, because if I talk about the digital speech processing, then why we require that we should know that digital speech the speech perception kind of things. Now, if you see that human being, ultimately we want to copy the human being through a machine, or we can say we want to develop an algorithm or technology by which a machine can act as a human being, or we can use the speech communication among the human being, and that communication we want to establish in machine. Okay. Now, if I want to do that in speech communication, if you see speech production and speech perception. So, 2 parts: speech production, the human being produce the speech and listeners perceive the speech. Okay. So, better we understand the how human being perceive the speech, we can better model that, we can better process the speech signal that way. On the other hand, if I say, if I produce a speech and a human listener perceive the speech, how human listener process the speech to perceive it is very important to know, because unless we do not know what we perceive, the development of technology will be not possible. So, we want to know what kind of speech processing happen in our brain, and if try to follow that kind of processing in digital speech domain, so that we can develop the speech technology. Like the speech coding, if you see that speech let us the example of speech recognition and speech coding, or speech recognition, let us the example of speech recognition. So, what listeners is produce, what the speaker is produced, that listened by the listeners and he perceive. Same technology we want to produce in machine, that in front of a microphone we want to speak out that our speech signal or the speaker output we want to give, and from the microphone and the signal processing technique I want to develop how human being perceive the speech. So, if I want to develop that technology, we should know that signal processing involved in human brain, what kind of signal processing involved in the human brain. So, that we want to know, that is the speech perception, how we perceive the speech. Forget about this speech chain. So, if you see the auditory systems, we perceive the speech through the auditory systems of the human being. So, if I say that a human being, a human listeners first convert that acoustical signal to some nerval signal or nerve response, we can say. So, that require a transduction. So, transducer which will convert the input acoustical signal to a nerve signal, and that nervous signal, that the signal which is in the nerve will goes to the brain and process it and perceive the speech. So, we have there is a we can say the 2 part, or you can say the 3 part. One is called acoustical to neural converter, neural transduction and neural processing. Okay. So, acoustical signal has to be converted to the neuron signal, neural converter, and neuron has to be transmit the signal from that conversion point to the central brain for processing. So, here if you see the acoustical to this transversion, the acoustical signal first convert to neural representation by the ear. So, we have ear. So, function of the ear to convert that input acoustical signal to the neural signal, that is the process. Then neural transduction step take place between the output of the inner ear and neural pathway. That means, whatever the output is coming from the neural transduction has to be taken away to the processing unit, and nerve firing signal. So, auditory, there is a human brain, so brain process that firing signal and perceive or understand the speech. Okay. So, perceive and understanding is happen in brain. Okay. Now, we have to know what kind of transduction is happen and what kind of processing is happen in human brain. So, that two things we have to know the human perception, or rather I can say what kind of. So, if you study the microphone, the purpose of the microphone is that it has to be convert that acoustical signal to a electrical signal. Okay. Now, I have to know that this microphone has how efficiently this microphone can convert the acoustical signal to electrical signal, or I can say the properties of acoustical signal, how accurately impose on electrical signal, that is the electrical. So, acoustical signal is equivalent to electrical signal if the all properties of acoustical signal like that its frequency represent, or you can say frequency composition or its amplitude, all things how it is represented in electrical signal is the important point. So, that means how efficiently a microphone convert the acoustical signal to electrical signal is the property, or is the you can say the construction depends on the construction mechanism of the microphone. Similarly, human being has an ear, 2 ears, if you say 2 ears. So, how efficiently human ear can convert the input acoustical signal to the nerval signal or nerve signal. So, I want what kind of limitation this system is imposed on speech perception. That means, human being, or what kind of, you can say that what kind of constraint it put on the human speech signal conversion. So, that kind of constraint we can exploit in speech processing. So, that human being cannot hear that error. Okay. So, suppose a microphone has, if you see the microphone has a frequency response. Let us discuss about the frequency response. Suppose a microphone has a frequency response. If you know the frequency response, because frequency response is nothing but a frequency versus amplitude plot. That means, for a particular intensity sound of different frequency, how it represent in electrical signal. So, suppose a microphone has a frequency response whose flat area is around, let us from here it is 30 hertz to 10 kilohertz. Okay. So, that is data set is given, that this is the microphone. So, this microphone is efficient to convert the acoustical signal in between 30 hertz to 10 kilohertz and produce the electrical signal. So, if an acoustical signal consists of 12 kilohertz, the electrical signal should not contain that component, because that the response of the microphone at 12 kilohertz is almost 0, maybe almost 0. Let us say it is down in here is 12 kilohertz. So, it is 0, almost 0. So, I cannot get 12 kilohertz response in here. So, that means, the limitation which is imposed by the microphone in electrical signal is 30 hertz to 10 kilohertz. Similarly, suppose I have a human ear. So, acoustical signal human ear convert into nerval signal. So, perception of that signal, that how we perceive, what is the limitation of our perception, that is the limitation of conversion by the ear to nerval signal. So, limitation of perception, how weak signal we can perceive, which frequency we cannot perceive, all kind of limitation is imposed in here. So, if I say first impose is the 20 hertz to 20 kilohertz frequency we can hear. So, ear can convert only the acoustical signal which is lie between 20 hertz to 20 kilohertz. If I apply 22 kilohertz to the human ear, it will not perceive. It may not be converted to nervous system, or nervous system cannot represent or cannot sensitize a response in the human brain. Okay. So, I have to know how this signal or how this acoustical signal is converted to nerval signal. So, that is the physiological mechanism, we have to understand the physiological mechanism of the human ear. So, if you see, I come this one later, human has 2 ears, if you see, a human has 2 ears. Why a human has 2 ears? If I do not have 1 ear, what will be the problem? So, the 2 ears help to localize the sound, sound localization. If you close your eyes and if your sound is come from some direction, you can tell that some sound is coming from this direction. If the sound is coming from this direction, without seeing the source, you can identify the direction of the source. So, that means localization of the sound is because of we have 2 ears. If you see that there is a home, the stereo, earlier there is a mono, then comes stereo, then comes surround sound. So, all are effect of sound localization, because if it is stereo sound, that means we can identify the source of the direction or source direction from the sound. Dolby surround sound. Suppose you are watching a movie where a train is coming from left corner of the screen to right corner, that means it is a 3 dimensional, you are visualizing in a 2 dimensional respects. Now, if I say, suppose I am standing in here, a train is coming from this direction and it is going this direction. So, what is the effect of sound? If the train sound is coming from this direction, so I should able to localize the train sound is coming from my right hand this side, and the sound intensity will be increases when train come to my place, and when train is going away, then I can say the sound is coming from this direction. So, if I able to manipulate this effect, then I can say it is a surround sound, because sound is coming from this direction. So, I can understand, okay, sound is coming from this direction. Okay. So, sound localization is one of the major issues, because human has a 2 ears, that is why we can localize the sound. Second one is the focus attention on a particular sound, or you can say the noise cancellation. If you understand, if you study the radar signal processing in electronics, you know how the clutter noise is rejected or kind of things. So, if I have 2 ears, help human being to attention or focus on a particular sound. If in this class there is a 5 people are talking together, even at the 5 people are talking and their audio level is almost equal, I can make my attention to a particular student speaking. So, that means I can focus on a particular sound. That is one of the biggest property in human perception, that I can easily cancel the noise or the what is the definition of a noise? Unwanted signal is nothing but a noise. So, suppose I want to listen the student A sound. So, student B produce sound is noise to that. So, I can easily ignore the student B's voice and perceive the student A voice. So, I can easily focus on a particular sound, that is also because we have 2 ears. Okay. Now, once you put your headphone inside the ears, then localization is within the headphone, it is not outside. Once you put the headphone, sound is producing there only. So, whatever the sound ear is perceived, the localization happen in the headphone only. Okay. So, that is the sound localization issue. Now, if I come that I want to make the auditory model, auditory system model. So, I can say whole auditory system model, it include sound, the acoustical signal to nerval conversion and perception of that nerve signal by the brain. So, I can say human auditory system, or you can say the human perception of sound I want to model. Now, if I say want to model it, how can I model? Because a human being is perceived the sound, I cannot measure each and every point what is happening in the signal level, and I cannot do that things. So, I can think, let us the human sound perception is a black box. Now, how do you define, how do you find out a black box model property of a system? Suppose I have a system, I do not know anything, this is black box, I do not know system property, system things, nothing. Now, how do we determine? We excited the system with a particular signal or known signal, then try to find out the observation. Okay. So, I give an example. I do not know the system. If I put 2, it give output 4. If I put 3, it give output 9. If I give 4, it give output 16. If I able to observe this behavior, then if I able to plot 2, then 4, then 3, then 9, then I can know from the plot the behavior of this black box. So, that is nothing but I can say this is nothing but a square. So, x square, if x is the input, y is the output, y equal to x square. We can derive this system property from observing the known input, what is the behavior. Same black box model can be applied in human auditory system or human speech perception. Suppose I apply a particular frequency sound with a particular intensity, then I want to observe the human perception. So, this is you can say the physiological observation, and this is not a physiological, this is a physical input and physical output, but here I cannot get the physical output. So, I can say here I can give a physical input which is nothing but a sound, acoustical sound, and I observe the physiological observation and try to correlate what kind of stimulus, this is stimulus only, input signal, what kind of stimulus, what kind of physiological response is produced. Then try to find out what is this black box, how human being perceive the sound. So, what I said, I excited this black box with a different kind of known stimulus, and then I have to find out the physiological observation of human, and then try to correlate what kind of stimulus producing what kind of observation, and try to draw a conclusion what kind of processing is done by the human being. Okay. So, that is why if you say there is a 2 dimension of sound parameter, one is called physical dimension, another is called perceptual dimension. So, let us give an example, intensity of the acoustics wave I can easily measure. You can know I is equal to nothing but a p square by 2 rho c. Rho and c is the density and c is the velocity of the sound, rho p is the pressure wave, amplitude of the pressure wave. Then I can say intensity is nothing but a p square by 2 rho c. So, I can measure the sound intensity. You can say the sound intensity measured by decibel, I will come dB meter, I can easily measure the intensity of a sound. But once I say loudness, this sound is louder than the previous sound. It does not mean the intensity of the first sound is twice than the previous sound. If I say this sound is twice louder than the previous sound, then I cannot say the current sound is not 2I or previous, or if the previous sound is I, it is 2I. The perception of loudness is human perception, but intensity is a physical parameter. So, perception, so there is two dimension, one is called physical dimension, where I can directly measure the quantity, measure the parameters, directly measure the parameter, intensity, frequency, all are directly measurable. But if I say loudness is a human behavior, physiological behavior of a human. So, I stimulate the human being by a intensity, and I want to observe that his behavior. Then observation behavior is called loudness and input is called intensity. So, there is a physical dimension and there is a perceptual dimension. Okay. So, I will come details on that physical dimension and perceptual dimension. Now, let us start with the physiology, or you can say the anatomy of human ears, some sort of a what is there in human ears. If you see, this is a color, nice pictures, so that there is a human being, human ears, So, there is a, you can say, the outer ear, which is this one only. If you see, this one is the outer ear. So, this is called pinna. So, what is the function of this pinna? If you see, if the sound wave is coming in this room in the medium air in a medium, now if I put a like that, if a sound wave is coming in this medium, if I put a area here, then sound wave will be strike here. Okay. Now, if the intensity of the sound wave is I, then what is the total power of the acoustical wave which is strike in this plate? If the area of the plate is A, then I can say the power or force is equal to I into A. So, I can say the principle of the pinna. So, working principle of the pinna is the, or you can say the work of the pinna is that it collects that acoustical wave and channelize it to the middle ear. So, if I increase the pinna, the channelized power will, acoustical power will be increases. That is why sometimes when we want to listen the very low sound, we put our hand in here. Once we put our hand in here, it increases the pinna area. So, more acoustical signal is channelized to there. Okay. Sometimes if you see the rabbits, to listen the sound, the rabbit can move his pinna. We cannot move my pinna. So, that is why we have a head movement. So, once I want to listen the sound, I can rotate the head, but if you see the rabbit can rotate their pinna to the direction of the sound. Okay. So, the pinna work is that it should channelize the acoustical wave power to the middle ear. That is the working of the pinna. So, if it is large, the more acoustical wave will be entered. If it is small, the area if the reduce, then a power will be reduced. Okay. So, that is the working principle of the outer pinna, outer ear or pinna. Pinna, you can say the pinna or pinna. Then there is a middle ear. Middle ear is what? Middle ear, that acoustical signal passes in the middle ear, and middle ear consists of a membrane and bone. I will come to the what is the work, and then inner ear has an cochlea. If you see, there is an cochlea. Okay. Now, so in the auditory canal, this is called auditory canal, middle ear auditory canal, acoustic wave is coming in here. Now, it is strike in this membrane. Once this acoustic wave is strike in the membrane, it produces the vibration. That vibration transmitted to the cochlea by a conduction process. So, there is a bone, and that bone, this acts as a mechanical resonator, or you can say not resonator, you can amplifier. We can mechanically amplify the sound and transmit to the cochlea. Okay. If you see the guitar, not that electronics guitar, if you see there is a mechanical amplifier, or you can resonator, you can say the resonator, that if it is not, that is not there, if I strike a string, the sound will be less, but if it is there, then it acts on mechanical resonator, then the sound is larger. So, that is the effect in here also, that this acts as a mechanical kind of things, and that transfer the sound to the cochlea. Okay. So, that vibration goes to the cochlea. Now, cochlea, so I am not reading the slide, you can read the slide. So, inner ear is the cochlea. So, this is the semicircular canal, and there is a cochlea. So, you know that the ear has two functions, this whole system has two functions, one is balance the body and another one is that listening. So, the inside the cochlea there is a basilar membrane which is responsible for listening the sound, and this semicircular canal. So, the cochlea is full of liquid. So, you can say that it is nothing but a packet of liquid. So, if I vibrate that outside wall of the liquid, then what will happen? That vibration will transfer to the liquid, and liquid is spread the vibration to everywhere. Okay. So, that is the mechanism for inner ear to perceive the sound, and this semicircular canal is full of liquid that acts the body balance. So, this is nothing but you can say the, if you see that sometimes when we are balancing, or you can say leveling some floor, we use the water balance. that to make a tube with full of water and then why to water level balancing we said whether the plane is correct or not, okay, where is the slope or kind of things. Similarly, this thing is used, we have two semicircular canal in two side and which is responsible for find out the body balance, okay, like that water balance. Same things is in here also. Okay. Now, in inner ear, so this is the basic description of the how human being or the function of that every and each and part of the human ear. Now, I go to the details. So, okay, this is physiological we understand. Now, in engineering model, so I should know what kind of action or what kind of things is happen in pinna, that is outer ear, and what kind of responses happen in the middle ear and the finally the inner ear. So, if I see the frequency response of the outer ear, that is the pinna. So, pinna, if you see that it is not channelize all frequencies same amplitude, I can say. So, what I say, the outer ear, if I see the frequency, this axis is the frequency and this is the response in dB. So, all frequency 0 dB is not same intensity, or you can say the 0 dB of 0, forget about the 0 hertz, let us 0.3 kilohertz, that means let us 300 hertz. So, 300 hertz sound of let us 0.5 dB, not less than 0.2 dB, and 1 kilohertz sound of 0.5 dB will be the same response, because it is amplifying, or you can say the amplification of the power, or I say the or all frequency by the outer ear is not same. Similarly, amplification or you can say the frequency response of the middle ear is not flat throughout the frequency, it also different frequency is a different response. Okay. If I combine these two middle and not middle and outer ear, the combined response is come as a red color. So, I can say human ear is not equal sensitive to all frequency. So, I can say we are not equally sensitive, or I can say let us 5 dB sound of 100 hertz and 5 dB sound of 2 kilohertz is not produce same intensity sensation or loudness sensation by the human in our human brain. So, this may be louder compared to this because of this response. So, if I inverted this curve, the curve will come like this. So, all if it is this is the frequency, this is the dB amplitude. So, all frequency has not equal response in case of human ear, that is the frequency response of human ear, that is the frequency response of a microphone. If it is flat for 300 hertz to 10 kilohertz, that means the microphone can produce the output or you can equal sensitive the frequency between the 300 hertz to 10 kilohertz, but other frequency the conversion from acoustical signal to electrical signal is very low, either very low or almost 0. Similarly, human ear is not sensitive or intensity sensitive to all frequency equally. So, the maybe here is 1 kilohertz, maybe after 5 kilohertz it also increasing. So, 5 dB of 100 hertz, 5 dB of 2 kilohertz, the intensity perception by the human being will be different. That is why we say because of this combined curve. I will come, this is called the threshold of hearing, I will come later on that one. Okay. So, now I am not describing that function of cochlear and all those things, you can read this is that this slide, that is nothing is there. So, I can say this is the schematic representation. So, pinna collect that acoustical signal, channelize to auditory canal, and middle ear convert that acoustical signal to a mechanical vibration, and that mechanical vibration transferred to the cochlea. Inside the cochlea there is a base layer membrane. So, this is apex and this is the beginning. So, this is the beginning of the cochlear, this is the apex of the cochlear. So, inside the cochlear there is a base layer membrane which is responsible for speech conversion of that mechanical motion to nerval signal. Okay. So, how it is done it? So, let us, I am not discussing here, let us in the next class I will discuss how the base layer membrane is converted, or you can responsible for or convert that vibration or motion, mechanical vibration to the nerval signal. Okay. Thank you.